It's the night of February 24th, 1989, and a living nightmare is unfolding over the dark Pacific Ocean. There has been a massive explosion on board a United Airlines Boeing 747, carrying over 350 passengers and crew. An enormous hole has opened up in the side of the aircraft, and the oxygen masks have dropped, but nobody, not even the pilots, can use them. The captain begins diving towards the ocean to get to a more breathable altitude, but his engines are catching fire, and he's having trouble controlling the aircraft. In the cabin, 9 passengers are missing. With more critical systems being lost by the minute, how will the crew be able to wrangle their jumbo jet back to the airport? This is the harrowing story of United Airlines Flight 811. On the night of February 24th, 1989, 337 passengers and 18 crew boarded United Airlines Flight 811 at Honolulu International Airport in Hawaii. They were bound for Auckland, New Zealand, a 9-hour journey. The aircraft they were flying on was a Boeing 747-100. It had been delivered to United Airlines almost 20 years previously, in 1970. By this point, the aircraft was beginning to show its age. Its engines weren't as fuel efficient as the more modern aircraft of the time. Its cockpit had old-fashioned analog dials instead of digital displays, and it was manned by a crew of 3, a captain, a first officer, and, sitting behind them, a flight engineer. Unbeknownst to anybody on board, this aging aircraft had one fatal flaw, which on this night would spell disaster. In command of the flight was one of United's most experienced captains, David Cronin. Cronin had been with the airline since 1954. Over his career, he had accumulated around 28,000 hours of flying time in a wide variety of aircraft, both military and civilian. At 59 years of age, he was approaching the mandatory retirement age of 60. In fact, Flight 811 was scheduled to be the second last flight of his career. Sitting to Cronin's right was 48-year-old First Officer Gregory Slater. Slater was also highly experienced, with 14,500 flight hours. Both he and the captain had been flying together for 20 years, and were well used to being a team. This night would be their greatest challenge yet. Sitting behind the pilots at the flight engineer station was 46-year-old Randall Thomas, who had about 20,000 flight hours. He would be the first of the flight crew to discover the true nature of the emergency on this night. In a few short minutes, this crew would need to draw on every minute of their experience to save the lives of all 300 plus people on board. They would be dealing with not one, but multiple critical emergencies. The particular combination of problems they would face would force them to throw away standard procedures and checklists, and to rely on their experience to make life and death decisions. All appeared well as the crew pushed back from the gate at Honolulu at just after 1:30 in the morning local time. The 337 passengers settled in for the 9-hour flight to Auckland and tried to get some sleep. With a full load of fuel and passengers, the plane was close to its maximum allowable takeoff weight of 320,000 kilograms. This would later become a critical concern for the pilots. At 1:52 a.m, the captain brought the plane into the air, and started to climb out over the Pacific Ocean. However Pacific the Pacific was reputed to be, on this night the sky above the ocean was anything but. Thunderstorms flanked the aircraft's route, and as the plane climbed, the pilots deviated to the left of these storms, keeping a close eye on both their weather radar and out the windscreen. Anticipating turbulence, Captain Cronin elected to keep the passenger seatbelt sign on. This decision would end up being incredibly consequential. 17 minutes after takeoff, as the aircraft climbed through 22,000 feet, a loud thump shook the plane. Just over half a second later, all hell broke loose. There was a deafening explosion, followed by a rapid decompression. Anything not tied down or strapped in was sucked out of a gaping hole in the aircraft's side. The cockpit erupted in warnings and alarm bells, as the pilots struggled to understand what had happened.
What the f*** was that? I don't know.
The noise on board was tremendous. The Lockerbie bombing had just happened 2 months earlier, and everybody on board Flight 811 assumed that a bomb had just gone off. At this point, the aircraft was flying 7 kilometers above the ocean. At this altitude, there is not enough oxygen in the air for humans to remain conscious for more than a few minutes. The captain immediately began an emergency descent, diving the aircraft to a more breathable altitude.
Put your mask on, Dave. Yeah.
The crew donned their oxygen masks, but found that they were not working. Whatever had caused the massive explosion had cut off their oxygen supply. From the cockpit, they couldn't see the hole that had now opened up in the aircraft's fuselage. If they couldn't get down to 10,000 feet quickly, they would risk losing consciousness, sealing the fate of everyone on board.
I can't get any oxygen. You okay? Yeah. Are you getting oxygen? We're not getting any oxygen. No, I'm not getting oxygen either.
There was no time to troubleshoot yet. The pilots would have to get the airplane down fast. As Cronin put the aircraft into a dive, he also began a left-hand turn back towards Honolulu, all while trying to keep the aircraft away from thunderstorms. But their problems were only just beginning.
Okay, looks like we've lost number 3 engine.
The instrument reading for engine number 3 on the right-hand side of the aircraft showed that it was vibrating violently, and that it wasn't producing any thrust. The crew had no choice but to shut the engine down. The pilots were now flying a fully loaded and badly damaged 747 on just 3 engines. The first officer declared a mayday to air traffic control.
Center United 811 Heavy, we're at mayday, we've got to come back. We had a bomb or something go off in the airplane. We're making a 180 and trying to get back to the airport.
United 811 Heavy, Honolulu Center, you're cleared to wreck Honolulu Airport, say altitude now.
Riley. Okay, we don't know what's going on. Looks like we've lost number 3 engine, and we're descending rapidly, coming back.
United 811 Heavy, roger, keep center advised.
The checklist for an explosive decompression requires the pilots lower the landing gear during the emergency descent, as this helps to stop the aircraft from getting too fast. But the crew suspected that given the explosion, the aircraft's structural integrity had been significantly compromised. They worried that lowering the landing gear would put stress on the airframe that it may not be able to bear, so they decided to keep the gear up. Ironically, the pilots were some of the few people on board who didn't know what had happened to the aircraft. The passengers and flight attendants sitting in the main cabin were all too aware of the nature of the emergency. A massive section of the fuselage on the right-hand side of the plane had simply blown off. The explosive decompression which followed had sucked out rows of seating and internal aircraft components, and with them, 9 passengers. Terrified passengers sitting near the hole were looking out into the pitch-black sky, and could hear nothing but the screaming of the 2 jet engines on that side and the howl of the air whooshing past the plane. One flight attendant was clinging onto his seat for dear life, and was hanging partially outside the aircraft. Her fellow crew members pulled her back inside, but she had been severely injured. Meanwhile, the flight attendants began running to fetch their portable oxygen bottles and trying to attach the face masks to them. Many had difficulty doing this, and began to feel lightheaded as the initial effects of hypoxia set in. Back in the cockpit, the situation was no less dire. In fact, the crew's problems had only just begun. After the pilots had shut down engine number 3, they noticed that engine number 4, the outboard engine on the right-hand side, was also damaged. The flight was well over 100 kilometers from Honolulu at this point. If engine 4 failed, the crew's chances of making it back to Honolulu would be significantly diminished. This problem was compounded by the fact that the aircraft weighed around 300 tons. Even maximum thrust on the 2 functioning engines was not enough to generate the speed needed to keep the aircraft aloft. As a result, the plane kept descending towards the ocean below. By this point, the crew had reached a breathable altitude, but their new problem was that their plane kept descending. It was too heavy to maintain altitude with just 2 functioning engines. The crew knew that their only hope of making it to Honolulu was by dumping fuel. This would make the aircraft lighter, which would slow its rate of descent towards the ocean. If they were lucky, they might be able to stretch their descent all the way to Honolulu. They began dumping fuel and contacted air traffic control.
Okay, it appears that we have lost number 3 engine, and we've lost. We're not getting full power out of number 4. We're not able to hold an altitude right now. We're dumping fuel, so I think we're going to be able to hold an altitude here shortly.
9811 Heavy, roger. Show you 60 miles south of Honolulu at this time.
Roger.
Seconds later, engine number 4 caught fire. Massive tendrils of flame extended out behind the shuddering engine. For the passengers with a view of what was going on, the scene was like something out of a nightmare. The crew had no choice but to shut it down.
We got a fire on the right side. We're on 2 engines now.
9811 Heavy, roger.
They were now grossly overweight and flying on only 2 engines. There was no way the crew could maintain altitude like this, and given their distance to Honolulu, it was beginning to look like they would have to ditch the aircraft in the Pacific Ocean. At night, with no reliable way to judge their height above the water, an attempt at ditching would leave few, if any, survivors. As both the functioning engines were on the left-hand side of the aircraft, the plane began to veer to the right. The captain had to stomp on the left rudder to keep the aircraft flying in a straight line. This took considerable force, and the deflection of the rudder into the slipstream created drag, which made the plane drop even faster towards the ocean.
We've got a heck of a control problem here. I've got almost full rudder on this thing. You dumping as quick as you can? I'm dumping everything.
Even still, the aircraft was descending. The 2 remaining engines were running at takeoff thrust, a setting they should only be left at for 4 minutes at most. Any longer, and this would risk damaging them. Yet the crew's options were limited. If they reduced the engine thrust to spare the engines, the aircraft would lose speed and descend even faster towards the ocean below. The first officer asked the captain if he was able to keep the airspeed high enough to slow their descent.
Can you maintain 240? Yeah, just barely. Yeah, but we're losing altitude. I know it. We're dumping 5,000 pounds a minute.
All while this was happening, the aircraft had started drifting off course due to the asymmetric thrust.
Okay, watch your heading, watch your heading. You're going direct to, you want to go direct to Honolulu.
To the passengers, the danger was the gigantic hole in the side of the plane. Would it open up further and rip the plane apart? To the pilots, on the other hand, the danger was the sheer distance between their aircraft and Honolulu. With every passing minute, they were descending ever closer towards the dark Pacific Ocean. All the while, the aircraft was quivering and shuddering, a result of the aerodynamic disturbance caused by the massive hole in the fuselage. Nobody was sure whether it would hold out for long.
Okay, I'm going downstairs to see what the hell's going on. Go ahead and run down and see what's happening. What a heck of a thing to happen on your second to last month. No shit.
As soon as the flight engineer descended the spiral staircase to the lower deck of the 747, he was stunned by the sight that met him. In front of him, on the right-hand side of the plane, was a massive hole in the fuselage, which was later described as being big enough to drive a semi-truck through. Beyond it, nothing but dark, empty sky, a battered wing, and 2 rattling jet engines. He sprinted back up the stairs to the cockpit and told the pilots that it looked like a bomb had gone off. He told them that a whole section of the fuselage was gone, and that some passengers had likely been lost. The captain informed air traffic control.
Hey, it looks like we got a bomb that went off on the right side. The whole right side is gone.
The flight engineer told the captain that given the damage to the aircraft, he shouldn't fly faster than 250 knots, as this would risk putting the aircraft structure under stress, which may tear it apart. At the same time, the first officer told the captain not to go below 240 knots, as the aircraft may become hard to control below that speed. This left the captain very little room for error. He had to keep his aircraft flying within a 10-knot speed window, on 2 engines, all while trying to maintain altitude and navigate back to Honolulu in the dark, The pilots didn't know it yet, but the engines were not the only parts of the plane that had been damaged. When the explosion occurred, the debris ejected from the fuselage had impacted the leading edge of the right wing, as well as the horizontal stabilizer and even the vertical stabilizer in the tailplane. Crucially, the leading edge flaps on the wing were dented and punctured. These flaps allowed the plane to fly at slower speeds during approach and landing. Without flaps, the plane would have to land at a much higher speed than normal. This is an emergency even when everything else is working. But in the damaged state that Flight 811 was in, there was a very real possibility that the aircraft would come apart on the runway if it touched down at these speeds. But this was not a problem the pilots were currently contending with. Their concern was what would happen when they lowered the gear. They feared that the landing gear system had been damaged by the explosion. When it came time to land the plane, would they even be able to lower the gear? The plane continued descending, despite the captain's best efforts. The controller had cleared them down to 6,000 feet, but they had now gone below this, and were approaching 4,000 feet. However, by this point, their descent had slowed. It was beginning to look like they might make it to the airport. Cautiously optimistic, the pilots began to set the plane up for landing.
What's the longest runway? 8 right, I believe it is.
Without flaps, the crew would be landing much faster than normal. The captain wanted the longest runway to land on, as this would reduce the likelihood that he would go off the end on landing. The controller began giving the pilots directions to set them up for an approach to runway 8 left at Honolulu, but the first officer noticed that the plane was starting to slow down.
Watch your airspeed. I got max on here.
Even with full power, the aircraft's speed was beginning to drop.
I don't know if we're going to make this. I can't hold altitude. Okay, well, we have 24 miles to go, and we're drifting down slowly, so you're going to make it. Make sure we don't hit any fucking hills on the way.
Air traffic control continued giving the crew radar vectors to line them up with the runway. The crew tuned their navigation radios to the ILS frequency for runway 8 left, the longest runway at Honolulu. An ILS approach would allow them to use their instruments to accurately determine whether they were on the correct path to the runway, even if clouds or rain obscured their view. At 17 miles from the runway, the crew began experimenting with the flaps. If they could get them extended, it could potentially be life-saving. The captain decided to do this cautiously, extending them one increment at a time.
Let's try 1 degree and see what happens. How do the controls feel? Alright so far. How about 5 degrees? Coming to 5. Tell me if the controls change.
The first officer monitored the flap position indicator and saw exactly what he was hoping not to see. He saw what is known as a split flap. The flaps on the outer edge of one wing had remained in the retracted position, while on the other wing they had extended. The purpose of flaps is to create lift, which is the force that pulls the aircraft up. If one wing produces more lift than the other, that wing rises by itself, and the plane tips over on its side. The pilots knew when they got this split flap indication that if they extended the flaps any more, they risked having the aircraft spiral uncontrollably into the ocean below.
Okay, we're getting a split flap on the outboards. Let's just land with 5 degrees. Give me a speed for 5 degrees, alright?
Second Officer Thomas consulted the landing speed chart and told Cronin that the landing speed for flaps at 5 degrees was 190 knots. This was well above the typical landing speed of about 150 knots. The first officer persuaded the captain that it would be worth trying for 10 degrees of flaps, as this would reduce their landing speed. They tried this, and it worked. The plane was controllable, and they were able to fly slightly slower. Captain Cronin then began a right-hand turn to line the massive aircraft up with the runway. Finally, the runway came into view, and air traffic control cleared the flight to land. This was a welcome sight to the pilots, but the ordeal was far from over. How would the plane handle at the much lower speeds closer to landing? Would the landing gear extend? And if it did, Would it hold once they had touched down? What about the aircraft itself? Would the aircraft hold? But the pilots could only deal with one problem at a time.
Okay, well, let's try the gear. Okay, trying the gear. You ready? Okay.
The pilots watched intently as the gear slowly extended and locked into place, as confirmed by the green indicator lights. This came as a massive relief, but the real test was still ahead of them.
I hear people screaming back there. Give them a 3-minute warning. Tell her on the PA.
Second Officer Thomas told the flight attendants to prepare for an evacuation on the runway. Everything was now set. The flaps were extended as far as the crew could safely get them, the landing gear were down, and the cabin crew had been told to evacuate after landing. All the pilots had to do now was get their plane on the runway and hope that it stayed in one piece. The captain had his hands full flying the aircraft towards the runway, so the first and second officers helped him keep his speed and altitude in check.
I'd say aim for about 190 knots on touchdown. I wouldn't get any slower than 200. No, I wouldn't either.
The flight engineer then confirmed that the plane's hydraulic systems were all in good condition. This came as great relief to the pilots, as it meant that the brakes were likely working as normal. However, they would only be able to use reverse thrust on the engines on the left-hand side of the plane, which would increase their stopping distance. This was concerning, given that they would already be landing fast, and would need every bit of runway they could get. The captain's attention was focused fully on the runway as he carefully manipulated the flight controls in the final seconds before touchdown. The first officer monitored the instruments closely and provided the captain with airspeed and altitude information.
Looking good. 192, dot and a half high. 185, a little slow, Dave, below what we want. 190, coming up to the glide slope. You got the gear down, we're clear to land. Everything's done as far as we know. 200. 195, half a dot high. Looking good. 192. 195. Coming off on the power. 100 feet. 50 feet. Center of the trim, 30. 10. We're on. Gears holding. No spoilers. I'm going to go into reverse. On number 2 only, because we got 170. 160. 140. 130.
Finally, the plane slowed to a stop. The pilots shut the aircraft down on the runway, and the captain gave the order to evacuate. The 328 passengers evacuated the massive aircraft in just 45 seconds. About 25 minutes had elapsed since the explosive decompression. Unfortunately, the 9 passengers who were sucked out of the plane were never found. But what had caused this catastrophe to begin with? Was there a bomb on board? Investigators who examined the aircraft were quickly able to rule this out. Instead, they found something potentially more troubling, as it suggested that this incident may be one of many just waiting to happen. They determined that the aircraft had been mishandled by ground crews while at the gate. Careless operation of the forward cargo door by ground crews at Honolulu had apparently damaged its locking mechanism. This had meant that the door had never properly closed, and as the plane began to pressurize in flight, it blew open, taking a huge section of fuselage with it. Except, here's where it gets interesting. That would have been the story I'm currently telling, were it not for the parents of one of the victims, Lee Campbell. Kevin and Susan Campbell of New Zealand were not satisfied with the National Transportation Safety Board's investigation, so they began their own. Kevin Campbell had a background in mechanical engineering, and he spent months poring through thousands of pages of documentation about the 747's cargo doors. From their investigations, the Campbells uncovered a disturbing trend. It turned out that Boeing had received dozens of complaints of 747 cargo doors opening uncommanded as far back as 1975. In fact, just 2 years before the crash of Flight 811, A Pan Am 747 had its cargo door unlatched shortly after takeoff from London. In that case, 2 hooks on the door frame were the only things keeping the door from swinging open. It appeared that what had caused these incidents was not mishandling by ground crews, but faulty electrical wiring in the door's locking mechanism. When this wiring short-circuited, the door would begin opening by itself. This was a serious design flaw in the Boeing 747. Almost 2 years after the crash, when an extensive search operation had located the missing cargo door and dredged it up from the bottom of the ocean, the Campbells were vindicated. There was indeed a fault with the electrical system which controlled the locking mechanism of the door. On Flight 811, this system experienced a short circuit, which led to the cargo door unlatching mid-flight. In the face of this physical evidence, the NTSB had no choice but to accept the Campbells' conclusions. Faulty wiring and deficiencies in the cargo door's design, and not human error, had caused this accident. The NTSB recommended that all 747-100s in service at the time have their cargo door latching mechanisms replaced with new, redesigned locks, which could not fall prey to the same electrical malfunction. Since these changes were made, no similar incidents have happened on Boeing 747s.